Hello everyone, good evening. In the previous data structures class, I have explained how to convert infix expression to postfix expression, and the theoretical concepts with examples is done in one class, and in the other class I have explained how to write a program for the same. And in today's class what we will be seeing is it's a continuation of the previous class. Many students had requested me to give more examples, and in case you are a university student, there is another way of representing your solution, which is what most of the students asked me, because if you are preparing for placements, then all you have to know is how to convert, how the logic works. You need to know the logic, you need to know the algorithm, and you need to know the program. That's it. But if you are, that is already covered. And if you are a student who is taking your university exams, okay, can be SRM University, VTU, BU, anything. So if you are preparing for university exam, then presentation of your answer is important. So many students wanted me to explain the table method of presenting the answer when we convert from infix to postfix expression. The rules remain same, but how you have to write a descriptive answer, that is if you're taking a descriptive exam, how to write the answer. So that is what we are going to see in today's class. I will be explaining, I'll be solving many examples, and I will show you how to do it using that table method. It is actually not a different method. The same rules what I had told earlier in the previous class, same rules is applicable. Just you're going to express it in a different way because you're writing it on a sheet of paper. Okay, fine. So we will see infix to, and many students had asked me why should we convert from infix to postfix expression. Can't we solve using infix expression itself? It is possible to solve an expression in its infix format itself, but the time complexity will be more. So again, many students also ask me to explain how to calculate time complexity and space complexity. See, I had told in one of the previous videos what is time complexity and space complexity, but how to calculate it is different for each algorithm, and you will learn it as a separate subject called analysis and design of algorithms. In that subject you will have completely how to solve or how to calculate. Basically space complexity we will not consider, we will consider time complexity, but there will be very few examples to also know how to find space complexity. But as of now, to know which algorithm is preferred or which method is preferred, all you have to know is the loop, the programs or the algorithms or the procedure that takes less number of loops or less number of inner loops. So that is going to be preferred. Say for example, I'll just give you one small example. It's not a detailed example, just one small example. Suppose I have a for loop, okay. So this is about example for time complexity, okay, not a detailed one, just a basic example for you to understand why we prefer one method over the other. So if you have a for loop for I equals to 1, that is I need to print numbers from 1 to n. Just print numbers from 1 to n like this, 1, 2, 3, 4, like this, okay. Now this is my program. Now how will I solve this? I will write one for loop, right? For I equals to 1, I less than equal to n, I plus plus, and here I will write a printf statement. We will write the number in each and every line. Whatever is I, we are going to write it. So that's all. So this is going to print numbers from 1 to n in this order. Now, how many times does this loop execute? This loop executes n times, right? This loops execute n times. So if I give n 100, then this loop executes 100 times. If I give n as 1000, then this loop executes 1000 times. And if I give n as just 5, the loop will execute 5 times. So we say time complexity or the order of this particular loop is order of n, is represented as O of n. This is read as order of n. This is what you are going to learn in time complexity. Basically in your next topic, which is your design and analysis of algorithms, it's a completely different subject, where for each and every algorithm you're going to calculate such complexities. Okay, so order of n, this is called as order of n. Suppose I want to print multiplication tables of a given number. So I want to print multiplication tables of some number. I'll give one number, and for that number I'll have to print. Again there, say I have to print up to 10. That is also, instead of just printing I am going to print n star I, that's all, isn't it? Here, if I say enter a number, if the number I enter is 5, it is going to print, instead of 1, 2, 3, 4, 5, it's going to print 5 into 1, 5 into 2, 5 into 3. So basically I'll get 5, 10, 15, 20 like this. Suppose I want it in a table format, that is 5 into 1 equals to 5, 5 into 2 equals to 10. Even this also executes n times only. All I have to change is only this printf statement. Percentage d into percentage d equals to percentage d. So that's what I have to give. So n comma I comma n star I. So this will print, this will give this kind of output. Okay, so 5 into 4 equals to 20. So like this the output will be displayed. Now here this is going to be 10 or something. So from 5 into 1 up to 5 into 10 I will get the output. Okay, so this is also order of n because I have only one loop. Now suppose I want to print a triangular format or multiplication tables of numbers from 1 to n. Okay, so I need to print like this. I have to print 1 into 1 equals to 1, 1 into 2 equals to 2, like this. I have to display up to 1 tens are, then some stars. Okay, so just to denote end of first multiplication table, and then I will print 2 into 1 equals to 2, 2 into 2 equals to 4, like this. I keep on printing up to 2 tens are 20, again stars. Okay, so like this I have to print up to n. So in this case I will require 2 loops. This is my outer for loop where I will write whatever is n, that I will be writing here. So this is the inner for loop for j equals to 1, j less than equal to 10, j plus plus, and in the printf statement I will write the same thing, percentage d into percentage d equals to percentage d slash n. Here we will write I comma j comma I star j, and outside this loop I'll write those stars. So after first multiplication table it will print this line of stars. Okay, so this is my loop for printing this kind of output, wherein I am printing the multiplication tables of 1 to n. Every number I am printing from 1 to 10. Okay, so here I have 2 loops. For every value of I, j executes 10 times. Okay, when I is 1, j executes 10 times because j's value is from 1 to 10. Okay, then when j becomes 11, the inner loop gets becomes false, and we go to the outer loop where I becomes 2. Again j executes 10 times from value 1 to 10. Understood? So if I is there up to, if for I also if I give 10, then overall a statement is getting executed 100 times, isn't it? 100 times, because for every value of I, this statement is executed for 10 times. So if I have I n as 10, then outer loop executes for 10 times, and for every value of the outer loop, inner loop executes for 10 times. So totally it will execute, this particular statement will execute for 100 times. Basically, whenever you have 2 loops like this, one inside the other, then we say order of n square. Okay, because for every value we have again n number of loops happening. Here it need not be same. See, I told you like here 10 and here 10. It need not be same always. It can be 5 here, it can be 20 here, or it can be just 2 here, whatever it is. Whenever there are inner loops, we say it is order of n square. So here time complexity of this is more than time complexity of this one. So order of n square means if there is an algorithm which has time complexity as order of n square, takes more time to execute than the program for which the order is n. Similarly, matrix multiplication you have done. In matrix multiplication we have 3 for loops, right? So there the order will be n cube, means that takes more time than even this n square program. So that is called time complexity. So the more and more is the power of n, the complexity of the algorithm or the time taken by the algorithm to solve will be more. Okay, therefore, and we'll have some loops like we did sorting and all that. In sorting we try to reduce the number of times the loop gets executed, while we did prime numbers. Okay, while we did prime numbers we took I less than n by 2. So to make sure the loop gets executed very less number of times. So in such cases it will be order of log n. So log n is least compared to all these other orders. So like this you will know how to calculate and all. There are some calculations which is completely out of data structure, so I am not going to get into that details. I will be doing videos for that also, but not now. Okay, once this C and data structures gets over, next I will be starting with C++ and analysis of algorithms, DBMS and all those things. Okay, so when I am doing videos for those subjects in detail we will see about that. Okay, now why we discussed this is many students asked me, can't we evaluate an infix expression? So I have told them that it is possible to evaluate an infix expression, but the time complexity will be more. Why? Because we will have to do the loops many times, because as soon as we get a closing bracket, we have to go back to the expression, start repeating until there is an opening bracket. So since too much of to and fro needs to be done if we have to evaluate an infix expression, so to make it simple we will arrange them based on priorities, whether bracket is present or not present. Based on the priority we are going to first rearrange them in a different way, either prefix or postfix. Then we are going to evaluate that modified expression. So converting to prefix and postfix, the logic is more or less similar. We have already discussed postfix expression. In the upcoming classes I will also explain how to convert it to prefix, and the difficulty level for executing prefix or postfix expression is same. But as a standard, all the compilers or all the systems, all the processes are implemented such that infix expression is converted to postfix, and then evaluation of postfix is done. Okay, right. So that is the reason we convert it before evaluating. Now I have already explained you the details or rules for conversion of infix to postfix expression. So what are the rules? If you get an operand, I think you remember the rules. If you get if you read an operand or a variable, okay, what is the operand? It is a value upon which the arithmetic operation needs to be performed. So if you read an operand or a variable, then copy it to postfix array. Okay, postfix array. If you get an operator, then we have further 3 rules. What is that? If it is an opening bracket, push to the stack. Okay, if it's a left, this is also called as left parenthesis. So if it's a left parenthesis, push to the stack. Okay, if it's a right parenthesis, pop items from stack. Okay, pop items from stack until you get a left parenthesis. Okay, so until you get a left parenthesis, you need to keep popping elements from the stack and copy to postfix. Okay, copy to postfix array. So this is in case of left and right parenthesis. Suppose you don't have this left and right parenthesis and you are getting an operator, then any other operator like plus, star, slash, minus, modulus and the this operator. Okay, so any of these operators if you get, then you have to check priority of operator at the top of the stack. So see what operator is there in the top of the stack. Okay, if stack top priority is equal to or greater, okay, if the stack has an operator at the top whose priority is equal to or greater than the new symbol, greater than the new operator, then pop it and copy it to postfix. Whatever we pop from the stack, we need to copy it to postfix. Else, if it's not greater, that is, see, stack has plus in the top first character, and now you are reading a star. So star and plus you compare. So the character at the top of the stack is plus, and its priority is lesser than the new operator, which is star. Then you will just insert that new operator to, else push new operator to stack. Okay, suppose in stack top you have star and now you want to copy plus. Plus has lesser priority than star, or in other words, stack has an operator whose priority is greater than the new operator. So pop it and copy to postfix, and this has to be repeated until you get the same thing. And note is, this is for priorities. Left parenthesis has priority 0 and plus and minus has priority 1, and then you have star and slash has priority 2, and modulus also is priority 2. Power, okay, this is priority 3. That's all. Okay, this is about the priorities. Hope it is clear right now. With these rules, let's take some examples. Okay, so now let us take our first example, which is A power B star C slash D star E minus F. Okay, this is the infix expression. So I will first convert it manually, and then we will make sure we'll follow those rules, principles that I have just explained, and we will convert, and our answer is going to be same as what we are going to convert right now. So postfix expression is, this is power, so which is of highest priority over all. So it has to be basically A power B, right? So it is A power B, that has to happen first. With this answer we need to multiply C. So C comes here and then star goes next. So this is your entire numerator. This has to be divided by this denominator, and so this division operator comes in the end. So here you are going to get a DE star F minus and then slash. Okay, so this is your postfix expression. So basically what you have to do is you have to do A power B, and then with that answer you need to multiply C, and then D and E you need to add. With that answer you subtract F from that answer, and the first answer is divided by this second one. Okay, this is your postfix version of postfix expression is this. So this is the answer you are going to expect from your table method and also from the program. We have already written program, I have explained in the previous class. So the same program I will give this as input, and we will see. We'll give this as input and we expect this output. Okay, now as per the students, what they asked, they wanted how to write it in the table form. Okay, so let me do this. So this is going to be we need symbol, then I will write a procedure, and then okay, so 4 I will take. So I will write symbol, means one by one we are going to take the characters from infix expression. Okay, so this is action taken, and then this is your operator stack. Okay, operator stack. This is your postfix expression. Clear? So let's do this. So now I have created a table. So now let me take the characters one by one from the infix expression, and I am going to copy it to the stack or the postfix expression. We will convert it. Okay. So now one by one I will take. So what is the first character I have to take is A. This is a operator, right? Initially the stack is empty. Okay, always the operator stack is empty in the beginning. Okay, so now this is empty. Now what is the symbol that I have read? It is a operand, means a variable or a value. So that needs to be, so we have to copy to postfix expression. Okay, copy to postfix expression, so it becomes A. So next, what is the symbol? We have exclamatory, power symbol. So this power symbol, it is an operator. Since the stack is empty, push to the stack. So in stack, earlier it was empty, now we have pushed this character. Postfix expression, no change, it remains same. So the next character is B. B, since it is your operand, we copy it to postfix. So this becomes AB, and this doesn't change. So don't keep any of the fields empty. So wherever change is there, you do that, and the other one where change is not there, write it as it is, whatever is you have written previously, and to which one you are making change, that you write it here. So the next one is star. Star is an operator. Now when you have an operator, what is the rule? You check the top of the stack. The top of the stack operator, if it is lesser than the new operator, no, we will just push it. But if it is greater than or equal to the priority of the new operator, then we have to pop it, copy it to the postfix, and then push this new character. Now star's priority is lesser, means the top of the stack has power whose priority is 3. Right, I have just told you what are the priority numbers. So this priority is greater than the new character. So pop this one and add to postfix. Okay, and then push star to the stack. Because the top of the stack has higher priority, I first pop it, add it to postfix, and then I push the operator here. Clear? Next comes your C. So C has to be copied to postfix expression. Okay, so I'll write A, B power C. Here we have only star. So this is done, this is done. Next is slash. Now slash is an operator whose priority, the top of the stack's operator star is priority, and this one is equal. If it is equal also, we have to pop star, add to postfix, and then we need to push slash. Okay, so pop star, so that comes here, then push slash here. Okay, next is opening bracket. So whenever opening bracket is there, just push to the stack. When you have an opening bracket, that is left parenthesis, you are not at all bothered what is there on the top of the stack. You have to just push this symbol to the top of the stack. Earlier we had slash, along with that now I have the left parenthesis also. Here there is no change, it is A, B power C star. Next is D. So this D is copied to postfix. So here it is slash and left parenthesis. Here I have A, B power C star D. Next we have star. Now star needs to be copied. So star has a higher priority than this because left parenthesis priority is 0. Okay. So push to the stack. So we have slash, then opening bracket, then star. And here it's going to remain same. Next is E. For E, we will have to copy it to postfix. Okay, so here this remains same. We'll just copy it to postfix. So next is minus. It's an operator. So we will push star, we will pop star. Okay, so pop star, add it to postfix and add to postfix, and then push minus. Okay, so star goes to postfix, AB power C star DE star, and here slash opening bracket, star has gone there already. Now I have minus here. So next is F, and F should be copied to postfix. Okay, so you get AB power C star D E star F. Now the next one is closing bracket. So whenever you have closing bracket, pop until opening bracket and copy to postfix. But make sure closing and opening brackets you don't copy. So whenever we have a closing bracket, I will not copy that. I will not copy the opening bracket also into the postfix. But until opening bracket, I keep on doing pop operation. So now what is the first pop operation I do? I do minus. When I pop, minus character is the one that is popped, and that is added to the postfix expression. And here it becomes slash and opening bracket, and until you have this one you have to keep popping. Now that you have done popping until you have the left parenthesis, now all the remaining characters in the stack needs to be popped and copied to postfix. So in the next one, so this becomes empty, and AB star D E star F minus slash. Okay, now pop remaining operators. That's it. So this is now you check your expression. So we have AB power C star C D E star F minus this one. So we have got the exact same postfix expression based on the rules that we had mentioned earlier. So we just executed this. See, we get the exact same output. AB power C star D E star F minus slash. Okay. So the same expression we are getting from our, same output we are getting from our program as well. Is that clear? So hope this table method is clear for you. Try to do other examples in the same way. Make sure I would suggest you to write the action column also. But many of them, if you see many solutions, they don't write the action column. It's up to you. If it's given for 5-6 marks, I suggest you to write this action column also, or at least 3 columns is compulsorily required. Okay, so I'll just take another example and do the same thing, but without action operator. We'll just keep on filling your stack and expression column. Okay, so I will take infix expression. My infix expression is a plus b within braces slash c star d minus e power f. Okay, so here since brackets is there, that is to be done first. So what's going to be your postfix version of this? AB plus, okay, and then slash C is there, so that has to be done first. So you get C slash, and with this result you are going to multiply D, and then you will have to do this e power f, okay, ef power. Now with these results you will have to subtract it, okay. So this is going to be our postfix expression for the given question. Now let us do it without writing that action column quickly. So I'm going to write just 3 columns here. So this is the symbol being scanned, and this is the operator stack, okay, operator stack, and this is your postfix expression. Clear? Okay. So what is the first symbol that is scanned? Opening bracket, and we have to just copy to the operator stack, and there will be nothing here, so null, okay. A postfix expression is going to be null. Next one that you read is A, and since it is operand, operator stack remains same. Here for postfix it is copied. Next I have plus, and plus needs to be copied to the operator stack. Top of the stack is opening bracket, which is not at all considered, its priority is 0. Now along with that opening bracket I am going to add plus, and postfix expression remains same. So next I have B, and B is, since it is an operand, we need to copy it to postfix expression. So operator stack will not get modified, it remains same. Here it's going to be AB. So next I have closing bracket. Whenever there is a closing bracket, you have to pop all the characters from the stack until you get that opening bracket and copy them to postfix, excluding the left and right parenthesis. So now here it is going to be empty again, because we will be popping one character, which is plus, and after that you have opening brackets, which you have to just skip it. Next we have C, and this is going to remain empty, and C is copied here. The next character is star, and since the stack is empty, just push the star here. Here it's going to remain same, AB plus C. Next is D, so the operator stack remains star only. Here we have AB plus C, then D. Next we have minus, and minus is see, the star has higher priority than minus, so it has to be popped. So popped, and then minus is inserted here, and the popped character is stored here, plus CD star, okay. So next you have I think I have left one, no, I have left slash C. Okay, after right, I have left one thing here. There is something that I have left. Okay, I have left one. After closing bracket we have slash, and slash is going to be added here. So here it's going to be AB plus. Next is C. This is not empty, you will have slash here, okay. Then C is added, right. Next is star. So star has same priority as slash, so star is removed, it is added here, and then we are going to have star here, okay, correct. Next we have D. D is copied onto postfix expression. Next I have minus. Now minus is having lesser priority than star, so star we have to pop it, and then push minus, okay, right. Next is, after minus I have E. So since E is a operand, we just write AB plus C star D star E, and here it is minus only. Next is power symbol. and that is of higher priority, so it goes here itself, and then this remains same. Next we have F, and here it is minus and this, and here I'm going to have A plus C slash D star E, and then we have F. Okay, so now we have come to the end of expression. So after coming to the end of expression, we have to pop all the characters one by one, and we need to copy them onto the stack. Okay, copy them to the postfix. So copy all remaining characters to postfix, and then this is going to be in the reverse order: AB plus C slash D star EF, and then see power symbol is popped and it is copied, then minus symbol will be popped and copied. Okay, so this is how you write it using this method. Hope this is clear. Let me know if you have any doubts. Do you have any doubts? So if you are writing your university descriptive answers, then this is how you are going to write. So based on the marks or based on whatever your faculty has given the instruction, either write 3-column table where first column is a symbol, second column is operator stack, and the third one is postfix expression. For every character that you read, just write down what all changes happens in the stack as well as in the postfix expression. So in case required, you can also write action or description for your actions. Okay, so you can write descriptions also. It all depends on your marks allotment. Hope this is clear, and the program also we have I have explained in detail before. This is using arrays. So in the next class we'll be continuing with queues. Okay, so we have just seen how to implement a queue using an array, and then we will see there are different types of queues. There are actually many disadvantages of queues. To overcome the disadvantage of queues, many different variations of queues are introduced, and we will see what is the limitation of each and every type of queue and how to implement it, and what are the benefits of each and every queue, or the different types of queues, the differences also we can see in the next class. And in case you haven't yet joined any of your social media channels, then links have been present in the description. You can join them. We will be posting all the programs, soft copies of the programs that is being discussed in the class. So I think yesterday I have posted C programming classes programs. Okay, and today I'll be posting the other programs of data structures as well. So you can join the Telegram channel. Make sure you join the Telegram channel, and I'll be uploading all the important documents, programs, everything in that particular group. Okay, in that channel. If you want to learn data structures very well in depth with lots and lots of examples, see, if you need more and more examples, there is one book that is very good for learning data structures. It's very simple, clean, and very easily explained. And if you are already good in data structures, if you think you are you can learn all these things very easily, then I would recommend you to learn complete in-depth understanding of it. For that, there is a slightly advanced book which is too good. You don't have to know complete data structures to learn it, but if you are good in coding, I would recommend you to learn from that. If you are average or above average in coding, then you can refer C in-depth book with lots and lots of examples. So link to both of the books I have mentioned in the description. So you can buy those books through this link, and when you order it through the link, we will also be getting a small amount as a referral bonus. Okay, right. Okay, see you in the next class. Take care. Bye.